Thank you, everybody. תיקון קטן, 40 שנות ניסיון. אבל מי זוכר? TypeScript in Node.js, capabilities, limitations, and what it means for the future of JavaScript, or the longest talk title I've ever had. So, well, you've heard about me, all good. What is TypeScript? First of all, because we're talking about TypeScript support in Node.js, I want to talk about what is TypeScript. Don't worry, it's not going to be a long introduction. It's more of setting the stage for what is going to be. TypeScript is, first of all, something that you click on. TypeScript is a language, interface, complex. It's a superset of JavaScript, where you add stuff to JavaScript to explain the types of the various parameters and whatnot. It's also something that does type checking. I want to differentiate between the two. In addition, a language to JavaScript, and something that checks that the types are correct. So in this case, if add accepts two functions, two parameters, A and B, at the top, then TypeScript will stop and say, this call to add accepts three parameters, please fix it. And you can see the error there using the TypeScript compiler. So it's doing type checking. Transpiling. To run the TypeScript, we can't really use Node. If we use Node or the browser, then we get an error because Node or browser or any JavaScript runtime doesn't know what TypeScript is. So what we do is we use that same compiler and we emit JavaScript. We can even tell it, don't check types. Even if the types are incorrect, please emit the JavaScript. We're all good. So type checking and transpiling are two different things, and that is very important for the rest of the talk. We're used to having them in the same time, but they're different. So TypeScript is a language, type checking, transpiling. It does other things, declaration files, the transpiling, we don't care about that. But the important thing is you cannot execute TypeScript. So how until today did you execute TypeScript in Node.js? If we wanted to use TypeScript in Node.js, how did we do that? Let's say we have main.ts. It imports from complex.ts. We're going to see this a lot. Complex.ts is a library for complex. And when we add many, and we call it with two complex numbers. Everybody knows what a complex number is? מספר מרוכב, right? Real and imaginary. Okay. What we do, because we can't execute it, we transpile it. We say TSC, it looks for all the source files and copies them to dist, but as JavaScript files, not as TypeScript files. So main.ts will be dist/main.ts, complex.ts will be dist/complex.ts. And then we run main.js, in dist, and we get the response. This is how we run TypeScript. Is this fun? Absolutely not, and it is one of the reasons I did not like to use TypeScript in Node.js. I use JSDoc, there's a separate talk, never mind. It's not fun at all. What you can do is use tsnode and tsx, which change the Node.js runtime to support JavaScript. It munges the Node.js runtime to support JavaScript, but you have to run it using tsx and not using Node, tsx, main.ts, and we're good. So, not very important. But now we can do just this. Node src/main.ts, and it just runs magically. This doesn't. So let's talk about Node.js TypeScript support. You know, when I started, you know what I do. There's a CFP, something interests me, I just blindly deliver a title talk and then write a description, and I have no idea what I'm going to talk about. And then my talk gets accepted or not, but if it gets accepted, I looked at TypeScript in Node.js and I was like, there's nothing to say. It's like you just run Node and give it a TS file and you're done. What am I going to say for half an hour? We'll see. There's a lot to talk about, and it's incredibly interesting. It's incredibly interesting philosophically, and it points the way to how TypeScript works and how Node.js works and the future of JavaScript and TypeScript. So let's start with this. First of all, Node.js TypeScript support. As we saw, it works. That's one thing. Okay, I'll stay clear. But only from V22. V20 has no support for TypeScript. V22 and V24, the versions, you're not using V18, right? Nobody's using V18 or V16, right? Please don't. It's a security problem. So it's supported transparently. The nice thing about the Iran war was it used to have an experimental strip types flag that you had to do. Done. Not needed anymore. You just run your TypeScript with that, and you're done. So if you see blog posts with this thing, out. No need for it. It's not even in the documentation. So version 22, just run TypeScript and you're done. It's a very, very good reason to move to at least version 22. Okay, so this is our main code, but what about package code? Let's give an example. Let's say I import greet from greet. Greet is a package in Node modules, right? It's not a package in my code, and I call greet. Greet, when I do from greet, it goes to Node modules, finds the greet package, looks at the package JSON, and if the main says index.ts, index.ts will point to TypeScript package. Will this work? Unfortunately, no. The Marco Ippolito, who wrote the TypeScript support, bless him for Node.js, decided, not only him, but the rest of the Node TSC committee, not to support TypeScript in Node modules. Not because they couldn't, they could because they don't want to. Packages need to be distributed as JavaScript. Having the ability to distribute packages as TypeScript in terms of politics and the JavaScript ecosystem is very, very problematic. So they decided not to support TypeScript in Node modules. Me, I'm like tearing my hair, but because monorepos, packages in the monorepo, but that's what it is. Hopefully, something will change in that area. So we saw Node support for TypeScript. What about type checking? Does Node do type checking? Let's try. Look at this. We have, instead of reel, we have reels because we're Instagram fan. And obviously, when add many, obviously it's a type check error. So if I run a type checker on it, I get an error. Will Node throw a type check error? The answer is no. Node does not do type checking. So in this example, the reel will be not a number, nan. Okay? It does not do any type checking whatsoever. It just, well, we'll talk about what exactly it does in a second. So no type checking. So if you want type checking, you still need the TypeScript compiler. You still need TSC, or if you really want to go native, TSGo, as we learned in Josh's talk. So type checking still needs to be there. But don't forget, you can just do --no emit, which is just do type checking, don't create JavaScript files, because we don't need them. We can run the TypeScript directly. What tsconfig is good for type checking for Node. And we'll talk about that and we'll see more, but this is the beginning. The compiler options. The module should be, well, no emit is true. Instead of saying --no emit, just put it in the config file, the tsconfig.json. But module node next tells TypeScript this code uses Node semantics for Node modules, for resolution of Node modules. And since we're using Node.js, this is the best option that you should be using. So module node next, no emit, true. This is at least the minimum thing you want in your tsconfig. Obviously, you can add strict true and all the rest of the weird stuff in the tsconfig. Okay, so we did that, and we type check, and look what happens. It has a problem with import from complex.ts. Ooh, now we're going into a rabbit hole, and it's a really, really interesting rabbit hole. TypeScript doesn't like the .ts extension, which doesn't make sense. Why? First of all, why do we even need the extension? If we're front-end developers, or if we use CommonJS, we don't say .js or .ts or .whatever, tsx or whatever. We just write the name of the file. We don't add that extension. But Node.js ESM support forces us to have an extension. There's a talk I gave, lots of talks I give about Node.js ESM, and it explains why it forces developers, when they're doing import, to specify the extension of the file. The simple answer is it wants to be browser compatible. It wants to use the same module resolution as browsers, and that, for me, is a good thing. So ESM forces us to have an extension. But why doesn't TypeScript like the .ts extension? That's a good extension, and that's a good question. And let's step back and not think we're running the code using Node, but we're transpiling the code. So src/main is importing from complex.ts. And in terms of source code, it makes a lot of sense. This points to this, and we're good. Now we're transpiling it. This stays complex.ts, but the file here is complex.js, so there's a breakage. It doesn't find the file when running the dist file. Okay? Got it till now? .ts is problematic because when transpiling, it doesn't work anymore. Okay. It should be complex.ts transpiles to complex.js. Makes total sense, right? No. Why doesn't transpilation change the extension? And this we're going to get back to. TypeScript only wants to do type stripping. It wants to change as little as possible from the source code because it wants to keep as much as JavaScript as possible. So it does not want to change the extension, not even that. Changing the extension from .ts to .js counts as changing the source code, and they don't want to do that. So the code should be complex.js when transpiling. When transpiling, I should do this, and this works. This is perfect. Whoever used ESM and TypeScript knows this thing. But now we have a problem. This works when transpiled, but Node doesn't like it because there is no complex.js. So now we're in a problem. What do we do? Okay, TypeScript doesn't like TS. Node.js doesn't like JS. What do we do? And the answer is, well, config, allow importing TS extensions. Because we're not emitting. So we're telling TypeScript, when you're doing type checking, please allow TS files. It's fine. Don't worry about it. It's good. The runtime will take care of it. Again, only works with no emit. If you're emitting, this doesn't work. If you want to both emit and run and show my start menu, then rewrite relative import extensions is true, and you get best of both worlds. TypeScript only wants to do type stripping. Remember that. We'll get back to that. It is crazy important. ESM and CommonJS. We talked about ESM. What about CommonJS? Require. First of all, a small remembrance how Node knows whether a file is ESM or CommonJS. And the answer is it looks at the extension. If it's .mjs, then it's ESM. If it's .cjs, it's CommonJS. What if it's the standard .js? It looks at the package JSON. If the package JSON says type module, it's ESM. If it doesn't say type module, says something else or doesn't exist, it's CommonJS. Why? Because CommonJS is the default, so if there's nothing there, then it's CommonJS. So remember, it looks at the file extension to know whether it's ESM or CJS. And this is true for TypeScript. TypeScript also added, just like there's MJS and CJS, there's MTS and CTS. Nobody uses that, just so you know. So this works. We have a source/main.ts, and we're using CommonJS syntax for exporting something. This is great, no type module in Pocket.json. But there is an interesting thing. When ESM must have an extension when importing, CommonJS and JavaScript, no extension needed. It figures out the extension by itself. But CommonJS TypeScript must have an extension. Why? No idea. But it's just true. So remember, if you're writing CommonJS TypeScript in Node.js, you have to have an extension. It is what it is. Okay, now comes the interesting part. Type stripping versus type transformations. This is where the fun part begins. It used to be that we have a flag, experimental strip types. Notice the word strip types. Node.js strips the types from the code, and we'll see exactly what type stripping means here. We'll see it. We need to first understand how transpilation works internally. Node, when it transpiles, it goes through a library called Amaro. Amaro is the name of a mountain that Marco Ippolito saw from the window when he was developing TypeScript. Yes, so it's fun. It's an NPM library. Anybody can use it. It's called Amaro. It's cute. Under the hood, it uses something called SWC, which is WebAssembly. So the type stripping is incredibly fast. Okay, but that's Amaro. So I said to myself, well, let's use Amaro. It's just a library like anybody else to see the result of the transformation. So I wrote this show type stripping. It gets a file as an argument. It reads the file, does a transform with mode strip only. We'll talk about the other mode later, and just console logs what the result is. So I'm taking complex.ts and I'm stripping the types to complex.js. Let's see the result. This is the source. This is the transpiled. You see what's happening? See what he did there? He replaced, replaced the types with blanks. TypeScript doesn't do that. Has anybody seen what TypeScript does when it transforms the types? It squunges everything together. It doesn't care about type stripping. Just removes and replaces. It doesn't remove. It replaces it with blanks. Why? First of all, no need to understand the types. Amaro doesn't understand the types. It doesn't do type checking, nothing. So it just strips them. That's faster. But, and a more important thing, no need for source maps. When you throw an exception, first of all, no need for source maps for the debugger. Everything just works. Line and column, it's the same thing for the source and for like the destination, like the dist, which is internal in memory. No need for source maps for the debuggers. And let's say I throw an error here in add, and I call main, and it's line 7, right? Now and transpiled, it's still line 7, right? Still line 7 because I'm just replacing it with blanks. Now I run it. What does Node.js show us? Line 7, because for all intents and purposes, it's line 7 also in the transpiled version. So if it's line 7 here and line 7 here, it's great. I don't need to take the stack and start working on it and figuring out where the heck it was in the source code. Everything is the same. So no need for source map. This is genius, by the way. I love the idea. It first came from Bloomberg, which they called it TS blank spaces, something like that. And then Marco took it and created SWC. Amaro. Sorry, Marco created Amaro. Now let's look at this code. Can this code be TypeScript? A TypeScript? Yes. It works. What about this? Can this be TypeScript? Nope. Look at object.keys number types. It's not using the type as something that I can remove. It's using the number types as something real in JavaScript. I can't throw away the type. So I wrote this. Use mode transform. Like do everything. Don't just strip the types, transform everything, even enum. And what I got, this turned into this. This is what enum looks like in JavaScript. It's a real object called number types. Doesn't really matter the whole shimmingig, but I can't type strip this away. I can't replace it with blanks. I can't replace this with blanks because it's creating real JavaScript code. This is not type stripping. And when we run the code, we get TypeScript enum is not supported in strip-only mode. It will throw an error because it doesn't like it. It likes only to type strip. So we have experimental transform types, which also does the types transformation and supports enums, and it just works. TypeScript doesn't work on enums, namespaces, we'll get to that later, parameters, decorators, and imports of types without type keyword. And we'll talk about all of them. Let's talk about them. Let's see how we can ensure our TS code can be TypeScript. First of all, a good TS config for that would be to add erasable syntax only. This is a new TypeScript thing, which says only things that can be TypeScript can be erased from the code are supported. So if you use this and you try to use an enum, it throws an exception, it doesn't type check, and we're good. Now we know what we can use and what not. This verbatim modular syntax tells us that if you're importing a type, you must use the type keyword, and we'll see in a second what that means. But first, we'll talk later about why I think type stripping is the best and why I don't use transform types. But first off, what if I do have something like enum and I want to replace it? What are my options? Okay, remember, enums, namespaces, we'll go through one, and we need to replace them with something that Node can type strip away. We'll go from easy to hard. First of all, parameter properties. It's these things. Public real number. It does two things. It both gets them as a constructor and also defines the field in the class. So that's definitely not type strippable because it needs to define what the property is in the class. Desugaring is very easy. Just don't be lazy. Just define both the properties and the things in the constructor, and you're good. This is the easy one. Namespaces. A lot of you probably don't know what namespaces is, but this is an example. Namespace greetings has a function greet, and to call it, I do greetings.greet. Are you using namespaces? Stop. Even Microsoft doesn't like them. Stop using namespaces. But if you really want to do this, namespace is just an object. So if you have function greet, greetings as a namespace is just a const, it's just an object that has greet as a member, and now you call greetings.greet. You can scope it, whatever, I don't care about this, and we're done. Notice that type-only namespaces are fine. So if the namespace has only types, it's okay. We just erase them away. So that's fine. If your namespace is with only types, go ahead. Now, type imports. This is, let's say complex is a type, as we all know. What happens when we erase it? Not a problem. It's erasable, right? So why is this a problem for Node.js? Why can't it erase away? Easy. Node.js doesn't know that complex is a type. From it could be a real object, it could be a function, it could be whatever. It doesn't know, so it can't type strip it away. If it doesn't type strip it away and the export type strip it away, we get a clash here. So it must know the type, and it can't know the type because it doesn't understand types. We need TypeScript understanding, which is why it's a separate flag. You do add verbatim module syntax, and it won't allow you to do this. It just won't allow you. To solve this, import and you add a type complex. This is erased to this. The import still happens, but the type is gone. If you want to erase the import too, you do import and the type is outside the thing, and then all the import is erased. This is interesting. There are ESLint plugins that just do this for you. Very simple, and they have autofix, and you're just done. Okay, so use ESLint for these kinds of things. Decorators. Who uses decorators? Oh, sorry. My project too, but sorry. It's the strudel thing, the @ thing. I don't want to get into what you specify the functions, and it does all kinds of things. You can desugar them. You can remove it by just doing what the compiler does. I don't want to get into that, but it's definitely not type strippable. Decorators, incredibly enough, are stage 3. Okay, they are stage 3. And they are not part of the erasable syntax. Use a linter to get full of them. And when I say they're soon to be part of JavaScript, any day now, really, it's been like that for 2 or 3 years, I think. It's not going anywhere. And somebody on Blue Sky explained why. Browsers, for some reason, are reluctant to implement it. And until 2 browsers implement it, it'll stay in stage 3. It's basically there forever. My guess is it'll stay there for a few more years. Nest.js users, please cry. You're not part of the Node.js type stripping capabilities. I'm sorry to say. And now for the most controversial of all, enums. I have time. Enum, which may be a standard in JavaScript. They're talking about it, but these things take time. It may be a standard, but currently it's a TypeScript-only thing. What is probably going to happen is that when it is a standard, it will conform to the TypeScript way of doing things because there's so much code out there. But currently it's not. I can't really erase it. But I want to talk about what enums give us. First of all, you know what enum is. You just use the enum and the values inside it. We're good. But it also is what is called exhaustible. So if I have an if-else or a switch which exhausts all the enum values of the enum, then when you get to the last else, the NT will be a never type. It knows that it's exhausted all the possibilities, which is really, really nice. And it's enumerable. As we saw, I can do object keys of number type. One option is just use unions. That's my favorite. Just use unions, with real or complex, and you're good to go, and they're great. They're simple. They're very TypeScripty. Everybody uses them. They're exhaustible, so the last else here, NT will be never, no, not a problem. They are not enumerable, but I haven't seen a lot of places where enumerability is nice. And there's no numerical enums. You can't say, in enums you can say x equals 1, y equals 2. It has to be a string or a symbol. Option 2 is an object. Number type is real and complex, and now you add types, which I don't want to get into, to enable you to use them very simply. They're complex to write. You have those types that you need to add, very close to the original enum. They're exhaustible, they're enumerable, they support numerical enums. You want a whole exhaustible article on how to replace enums, Duality, amazing, amazing article. Okay. Why type stripping and not type transformation? Why stick to type stripping and not do experimental strip types? 1, you get better load time performance. Type stripping is very, very, very fast. Type transformation takes more time. Better runtime performance because you have all that baggage of JavaScript. And no complicated build step, no complicated configuration, and works well in Node 22 and above. This is relevant also for front-end, so I implore you, please use only erasable syntax also in your front-end code. Why? Because we're in a world where these things also run in Node.js. Your front-end code in tests and server-side rendering, etc., works also in Node.js. So one day you'll be able to use the Node.js type stripping support also in your front-end code. What does this tell us about the future of TypeScript? Not Microsoft. Oh, first of all, a very important disclaimer. I work at Microsoft. I have zero visibility into the TypeScript team except for a 1-hour talk with Daniel Rosenwasser, the PM of TypeScript, yesterday. But again, I'm not talking here as a Microsoft person. Microsoft lawyers, this is my opinion only. Disclaimer. I am one of the co-authors of the type annotations proposal, which discusses how to run TypeScript in JavaScript. But I have not participated in it in any meaningful way since submitting it to TC39. I am not part of it anymore. So as I said, there is a proposal in running TypeScript in JavaScript. And it is, if you look at the annotations, it supports erasable syntax only. We understood the whole thing of type stripping even back then, and that is how it was defined. For me, erasable syntax, i.e., not enums and not namespaces and all those things that we said, is the future of TypeScript. It's not the future of JavaScript. I think it's also the future of TypeScript, JavaScript, if the type proposal is accepted. Node.js, for me, is a proof of concept of erasable syntax. If it gets accepted by the community, it will be a de facto thing that TC39 hopefully will be able to say, this is something maybe that we can use, but especially also the TypeScript team. And for me, where Node.js goes, others follow, just like they did with ESM and package.json. So type stripping hopefully will become a thing and will become something that people rely on. Notice that all new syntax, it's been that for a while, in TypeScript is erasable. My guess is that the TypeScript, again, disclaimer, is that the TypeScript team will never add something that is not erasable by blanks because everybody is now reliant upon this. So type stripping is the future of JavaScript operability. Node v22 type stripping is stable. Please use it. It is great. I'm using it for a project of mine, and it's amazingly fun. And thank you very much.